Today you will find out why this galaxy is the most frequently cited object in scientific research on dark matter. What happened in the 1970s when a radio telescope was directed at it? We will literally fly inside it and discover why so many astronomy enthusiasts choose it as a target for photography and visual observation. Thanks to it, astronomers discovered something that goes far beyond the limits of what we see. So fasten your seatbelts and let's journey to NGC 3198. NGC 3198 is located in the constellation of Ursa Major, about 47 million light-years from Earth. It's a classic spiral galaxy, similar to the Milky Way, with clearly defined spiral arms filled with star-forming regions. That alone makes it interesting for astronomers, but its fame comes from something much greater, something invisible. In the 1970s, when Albert Boomsma, using the Westborg radio telescope in the Netherlands, pointed the instrument's dish towards the galaxy, he discovered that neutral hydrogen extended far beyond the visible path of the galaxy. In other words, the galaxy has a vast gaseous halo, and to see it, we need to step back a little. A few decades later, within the Halo Gas project, astronomers conducted the deepest observations in the 21 cm wavelength to detect the subtleties of this structure. The results? Neutral hydrogen forms a layer 3000 light-years thick, accounting for as much as 15% of the galaxy's total gas mass. When astronomers began to carefully measure the galaxy's rotational velocities, they noticed something that completely overturned the discussion on disk rotation dynamics. It was expected that the velocities of stars and gas would decrease with distance from the center, just like planets in the solar system orbit more slowly the further they are from the Sun. Instead, NGC 3198 showed something entirely different. Its rotation curve was almost flat. This meant that at the galaxy's edges, matter moves just as fast as it does near the center. This anomaly could mean only one thing. The galaxy contains a huge amount of invisible mass that gravitationally holds the stars in their orbits. Thus was born one of the strongest pieces of evidence for the existence of dark matter, a mysterious substance we cannot see, but which presence is essential to explain the behavior of galaxies. In this way, its flat rotation curve became almost iconic in astronomy textbooks. This galaxy has yet another story to tell. Astronomers have recorded two supernovae in it, explosions of massive stars. These outbursts often outshine the brightness of the entire galaxy. Thanks to such explosions, elements heavier than helium, oxygen, iron, and gold are released into space, providing the building blocks necessary for the formation of planets and life. Why do so many astronomy enthusiasts point their telescopes in this direction? Because of its beautifully developed spiral arms, which are well visible even in amateur photographs taken with mid-range equipment. They stretch widely and contain numerous star-forming regions, giving the galaxy a picturesque textbook appearance of a typical spiral. By adding narrowband filters, we can capture ionized hydrogen invisible in ordinary light. This gives our images an extra dimension and allows us to admire a world inaccessible to the naked eye. This is one of the galaxies in which stellar rotation curves in the galactic disk were studied, leading to the discovery of dark matter. Photographing and observing it through a telescope is therefore not only an aesthetic experience, but also a kind of touch of the history of astronomy. Let's remember that the image we are looking at is 47 million years old, much older than the history of our species on planet Earth.